And we are live. Hi everyone. How are you guys doing? Hello, hello, hello. Welcome, welcome, welcome everyone. Welcome. Hope you're all doing well. Miss Nonchalant, Omkar, Sherlock, Holmes. Hey, no. What late OP? What late OP? Hello. I hope that I'm audible. I hope that I'm visible. Can you all confirm, please? Hi Sony. Hi, hi Shreya, Miss Nonchalant, Wasim, Sushant, Dhruv, Aman Chaudhary. Can you confirm if I'm audible, visible? Sanskar, Sushant, yes. All right. Everything is fine. Can you increase voice level? Wait, I can. Hold on. Okay. Is that better? Everything is fine. Yes, you're visible. Awesome. I've been trying out some video. You're in a corner. All right. Okay. Is that better? So I will be in a corner in a while. I will be putting out the iPad screen front and center later. OBS OP, thank you. I've just been experimenting with some stuff. I've been learning I've been learning how to make OBS backdrops, and for the record I know that my my chair is making a sound, and I will get it fixed tomorrow. Abhishek, our lockdown warrior, is back. Who is with us today? You guys are with us today. There are no guests. There is nothing. I want to start doing this where it's just me and you guys talking about something, because I realize that this is a different kind of chill. So I don't have to worry about talking to anybody, and I can just um focus on the conversation between us, just focus on the topic. Very excited about today's topic. Dhruv, awesome. Everybody like the stream, guys. Like the stream. Somebody told me that why aren't you telling your chat to like and subscribe? And I said that, yeah, it doesn't occur to me, but yes, you should. My moderators will do that. Yes. Suti, thank you so much. All right. Like Coco Public. All right. So, how are you guys doing? What's been up? We haven't talked in a while. The last top talk we did was on neuroscience of Among Us, and so this topic has been something that's been on my mind for a while. And this month is when we will discuss what is reality, and today is supposed to be part one. I wanted to talk about all of space perception. I'm not sure if I'll be able to, because there is a lot, but we will try. And whatever is left, it's our channel, it's our time. We can always do another one. So we're going to relax and we're going to try and learn something. Yeah? You guys up for that? Next part on philosophy. So all the next parts, I saw a couple of people ask about philosophy and astronomy. Everything is going to come, but one at a time, yeah? Astronomy was supposed to be last week, but there was some difficulty, and we will be doing it soon. Thanks, guys. You guys are awesome. All right. Then that being said, let us begin. Now space, later philosophy. Absolutely. Wait, so let me begin with this. All right. How our brain perceives space. Why is it important? Why is it important to talk about how we perceive space? Think about this. You are sitting right now in your room, and you are surrounded by a lot of things. Maybe you're surrounded by a table, maybe surrounded by your chair. Your laptop is in front of you. You have in your brain a constantly evolving map of everything that is are happening around you at all times. Now, close your eyes right now. Close your eyes and try and visualize everything in your room. Try and visualize what is there in front of you. Try and visualize what is there behind you. Try and visualize what is there around you. Try and visualize what is there in the other room. Who is there in the other room? Try and visualize where they are in relation to you. Are they on your left? Are they on your right? And now open your eyes and realize how much of a role your brain plays in constantly giving you this sense of where you are in this world. The reason that this is so important is because in evolution, this question of where am I, was one of the first questions to have been asked and answered. So, right from animals in the jungle, this question of where am I has proven to be the most important. Where am I in relation to the world? Because you need to hunt, you need to find food, and you need to escape from predators. And all these things, and you need to look for a mate. All these things depend on you knowing where you are in relation to the world around you. And that is why so much of your neural resources has been spent in understanding this. So if you think about the core questions that you've asked in evolution, the questions would go something like, where am I? Next would be, when am I? Who am I? And why am I? And you can roughly think of this as the story of evolution. So the idea of space, the idea of time, followed by the idea of identity, followed by the idea of purpose. So this is how evolution has progressed. And while we will be talking about these two later, let us start with this and then move on to the next one. So our next topic, assuming that we finish everything today on space, the next topic is we will be talking about time. But that is later. Let's first discuss space. Let's first discuss, where am I? So, iPad new layer looks good. Thank you, Aman. I would rather call it identity crisis. Identity is nothing. It is just a social rule. Okay, we'll talk about it. Aditya Prasad, gonna watch it tomorrow. Busy today. Yeah, Aditya, have a wonderful evening. Watch it. Aram se. I'm surrounded by energy. Horika is saying. All right. Would this also take into consideration that we needed some space from other humans also? Yeah. So why parents don't perceive child's space? We will talk about that. We'll talk about personal space as well. So this is so fascinating as an architect, Srinidhi. Oh, that's very interesting. Because I was actually, while I was reading about this, I was actually thinking, and somebody had messaged me on Instagram and I couldn't reply, but because I didn't get time. But discussing architecture after we discuss today's topic is going to be very interesting. Architecture, design, road planning, how a city is formed, that whole thing is so important. Archit Pratap Singh, thank you for the super chat. I've joined just now. Can I catch up from this point? Oh yes, of course. We've just started, Archit. Take your time. Doctor on Jagrita stream and Doctor here is very different. Yeah, there are. Is that odd though? Because don't we all play different roles? It's not that odd. Welcome, Chaitali. Welcome to the chat. All right. So I think that Feel free to ask questions. Feel free to say any random tangent of thought that comes to your mind. The reason that I'm having conversations like this without any guest is so that we can have a conversation. So yeah, feel free to join in at any point. We can take this conversation anywhere. Apna hi channel hai. All right, so let's begin. Now, let's draw you, and this is your environment, and this is you being surrounded by everything, right? And when I gave you this example of, okay, close your eyes and try and imagine, what you did was actually imagine everything that is around you. But the reason that you knew that those things were around you was what? How did you know? How did you know that in front of you is a laptop? How did you know that next to you is a table or a chair? Now, I'll be asking you questions as well. This is not a one-way street. I'll be asking you questions, and I expect you to quickly reply in the chat so that I can move on. How do you know where you are? Since we're talking about space, through my eyes, Aryan. Absolutely. Tanush, can I request the chat to not ask for different topics while we are discussing one topic, because that doesn't, I mean, what's the point? There is enough time to request for other topics. There is a whole channel on Discord. Just try and, because if we are discussing something else, you will ask for neuroscience of space. So let's discuss neuroscience of space while we are doing it. Fitted in the subconscious, excellent. Sumed, eyes, brain, senses. Chandani, memory. Yes. Archit, perception on a momentary blue dot. Yes, Sachin. Carl Sagan. Memory, PFC. No, not PFC. Conscious mind, our brain remembers long-term memory. All right. All of them true. The initial answer that I'm looking for is that we perceive things through our senses. So if this is you, the reason that you are able to know what is around you is because that information has entered into your brain through your senses. So you've either seen something through your eyes or heard something. So sound, smell, touch, and taste. Now, out of these, the most important senses for you to know your surroundings is sight and sound. For animals, smell and taste are also important, and touch is also important. For us, the most important ones are sight, sound, followed by touch. We don't smell much, and we definitely don't taste much around us. SEK Gaming has said there are actually many more senses. SEK, we are going to talk about the ones that have a neuroscientific basis. And while I agree that it's interesting that we can talk about other senses, extrasensory perception, ESP, and all that, I believe that there is so much that we don't understand about sight and sound that, trust me, you don't need to go into sixth sense and seventh sense to have your mind blown. Okay, so understand the five senses first before even trying to think, is there a sixth sense? So the most important out of all of this is sight. Now, humans have evolved to primarily depend on what you see in your environment to form an idea of what is around you. So when we say neuroscience of space, when we look at the space around us, most of our information that we know because we see it, right? Can we agree on that? Sense of balance, sense of temperature, do we consider them? So this is very interesting. Both of the things that you said, sense of balance and sense of temperature, both of them actually form a part of touch. So it's a different conversation, but that the touch senses are what tells you where you are. So are you standing straight, are you upside down? And there is another sense called as the vestibular system, but yeah, we won't get into that. Primarily, our look at it this way: your sense of balance and your sense of temperature, forget about temperature, your sense of balance is not going to tell you if there is a tiger in front of you. And always take the example of the tiger, because that is one of the main reasons why it is important for you to know what is around you. So if you are here and there is a tiger here, wait, is that a tiger? Let's say that that is a tiger. It's a very sad looking tiger, but it can kill you. And if there is a tiger in front of you, you need to know A, is there a tiger? And B, where is the tiger? Right? Epic tiger. Thank you guys. Thank you. You guys are the most encouraging chat ever. Thank you so much. Sad looking tiger. No, the tiger is gonna kill you. Okay. Don't say sad looking tiger. You are gonna be sad if you can't perceive space properly. Okay, focus. So if you don't know where the tiger is and you don't know if what you're seeing is a tiger, then you're dead. So the most important reason why 3D perception is important is because of to survive, right? So that is why we are going to start off by talking about the visual system, because the world is what we see. Now there is a whole other conversation to be had as to how do people who are visually impaired perceive the world. Now that is a whole other discussion. I'll try to touch upon it today, but there is so much complexity in that, and it's actually a very interesting discussion. But let us try and get to that after we have understood this one, right? Now, what do you know about the visual system? Justice for tiger. Oh boy. Oh boy, वहां तक पहुंच गए यार. I want to know about this tiger. What's his story? Hungry tiger. Dr. Fatak, just to draw for you. Hey yaar, I don't draw that bad. Yeah, what is this? Malnourished tiger. So malnourished tiger is actually going to eat you much more, right? How we perceive space. Yes. Okay. So how do we perceive space? This is you. Suppose there is a tree. Okay. Now don't tell me that this is a malnourished tree. This is as good as a tree as I can make. Now you need to know where this tree is and how far this tree is away from you. So this tree is going to reach you in the form of light waves, right? Now let us remove this whole thing because you don't need it. The only thing you need to perceive the tree is your eye, right? Is that a good eye? That's the best eye you're going to get, so deal with it. Your eyes will perceive a whole green tree. Oh, come on, yeah. Fine, I'll make a brown. Happy? Now it is accurate. Cool. So the eyes will perceive the tree through its light waves. Now if we draw the eye more anatomically, then this is where the pupil is. Inside the eye there is something called as the lens, and at the back of the eye is a layer called as retina. Okay, so right off the bat, one interesting thing that happens is that while the tree is like this. As soon as the light waves hit the tree and reach your eye, they get inverted. So once the tree hits the back of your eye, which is the retina at the back of your eye, now the tree looks like this. Now this is step 1 of perception of space, in that everything that is you're seeing in the world outside is actually inverted at your retinal level, right? Step 1. Next up, suppose if I'm drawing two eyes like this, and if there is a tree in the middle, this tree, for this my left eye, this tree is on my right, and for my right eye, this tree is on my left. So this tree is going to hit the opposite side of my eye. So it is going to hit the left side of my left eye and the right side of my right eye. Basically what this means is that everything on your left goes to your right, and everything that is up goes down. And this is why in your retina the whole world is flipped left to right and up to down. Okay, so that is one thing that I wanted to tell you. So when you perceive space, everything around you, it is actually opposite. Now, for the longest time, what people thought was that the world that you're seeing cannot be upside down. So what people thought was, so even if something is upside down at your retina level, so even at the retina level something is upside down, surely once it goes into the brain, at some point this upside down will get converted into right side up. Surely, because we are seeing the world straight, so it cannot be that everything is upside down. So at some point वो सीधा हो जाता है. But now we are realizing that this never happens. Once it is upside down, as far as we know, there is no place in the brain that corrects it. We perceive the world upside down, but because we are used to seeing the world this way ever since we are born, this is normal for us. And one of the most interesting experiments that happened in this space is when they took a cat. Oh God, I have to draw a cat now. Okay, I'm gonna try. Let's see. Okay, screw it. I'm not gonna draw a cat. I'm just gonna write a cat. Now they took a cat and they made the cat wear spectacles. Okay, and those spectacles had inversion lenses in them. So what the spectacles does is that it is a piece of glass that converts the world upside down before it reaches the eye. So the eye is here. So before it reaches the eye, the lens converts the world upside down. So now what happens is that this upside down world enters the eye, and therefore it actually becomes upright. So now your retina is actually seeing the world as it really is. Now what happened? That cat for the next 2 weeks was unable to walk. So that cat kept bumping into walls, that cat kept falling over itself, it kept tripping, and it just couldn't walk. Because for that cat, everything was upside down, so it kept feeling giddy. And an interesting thing that happened was, after around, I think 10 to 12 days, suddenly the cat acted normally. Suddenly it could walk again, and it could act in the same way that it used to act. Then what happened? They took off the goggles. And now, as soon as they took off the goggles, the cat could again not walk for 10 to 12 days. And then again, it could start walking. So what they concluded was that inside your brain, there is, you can think of it as a software that is built to perceive the world the way it is upside down. And if you do change it, it takes some time, but that software updates itself. And then suddenly the whole world corrects itself, because your brain is now figuring out that, okay, something is wrong and let me invert it and see. And as soon as it is inverted, now you're able to do your stuff. And then once you take off those goggles, after you are used to it, it is as if the world is inverted all over again. And this doesn't happen just with cats. The experiment was conducted with human beings also, and the same thing happened. So the same thing happened where the whole world got upside down when you're wearing the spectacles. After a few days, it corrected itself. And the way the researcher described it was that the whole world turned in front of me. So as if in your brain, the software detected a glitch and just turned it by 90 degrees. So that I thought was a very interesting thing that our brain does, which is that everything you see, like you're editing a photograph, you can literally click a button and turn it by 90 degrees, turn it by 180 degrees if you want to. And of course, this is not something that is voluntarily possible, but this is something that your brain does. And try and understand that we haven't even entered the brain properly. We are still discussing how you perceive space at the level of the retina. Okay, so that should give you a sense of perspective. And yeah, now where are we? We saw a tree. Yes, we saw a tree. The tree hit the eye, it entered into the retina, it went upside down. Now there is an inverted tree. Fair enough. So far we have understood. Now what happens? The retina is actually composed of, millions of cells. It is composed of millions of retinal cells. And the couple of names that you may have heard of are called rods and cones. Okay, now here I'm going to take a break and see if you guys are following. Let's see. Okay, there's a lot of I'm so confused right now. Oh no, who's that? Bhavya, why are you confused? Inversion doesn't happen. Amazing cat, mustache wala cat. Nobody's gonna know. Just resize the tiger. Yeah, I should have done that actually. I should have resized the tiger. Do we see 3D object as 3D, or 3D converts to 2D in the brain? Archit, that's a very interesting question. I will get to that. Why are humans the only species that need spectacles? No, that's not true. There are other animals as well, but they just don't get it. A drunk cat with glasses. Adaptation. Yes. Instant evolution. Yes. The world is upside down. Yes. No. The world is what it is. We just perceive it in a specific way. Very slow. Badal gaye. World is upside down. Evolution is such an intense change. It's given our brains adapt to change. Yes. I sort of don't get it though. This only happens with humans. No, Chaitali, it happens with animals as well. The whole world is upside down. We are just used to it, kind of. Yes, 180 degrees. Did I say 90 degrees? I meant 180 degrees. Correct. How did the brain get to know what is ulta and sida? very long discussion and has a lot to do with gravity, has a lot to do with what you said, sense of balance. And there is something called as the vestibular system. So the vestibular system is what tells you if you are straight or ulta. So if I latkofy you from the ceiling, the world is not going to correct itself because gravity. But in outer space, if you've heard interviews with astronauts, there is no gravity. So in your, wait, अभी इतना बात किया तो अभी बता ही देता हूँ. In your ear, right, inside your ear there is something called as the vestibule. So what I drew here is the cochlea, but just behind the cochlea is, wait, let me draw it properly. There is a structure called as the vestibule, and the vestibule has these three loops called as the semicircular canals, and you can think of them as the X, Y, and Z axis, right? And in each one of those loops there is a liquid that is running around, it is turning, and every time the head moves, on both sides you have the XYZ axis which has this liquid running around. So as you turn, that liquid also turns, and the movement of that liquid tells your brain if you are turning to the left or to the right, front or back, are you hanging upside down or are you straight, and all of that happens because of gravity. So if there is no gravity, that fluid will not really turn because there's nothing to pull it down. So that is why it is very disorienting when you're in space, because even if you're upside down, you're not going to feel any nausea or anything. So that is how you get that sense of balance and upside down. Does vertigo screw over all of this? So vertigo is this. Vertigo is when our gyroscope, exactly. Gyroscope is this basically. My girlfriend experienced BPPV just last week. Yes, so this is what BPPV does. So BPPV is a benign positional paroxysmal vertigo. So when your fluid isn't turning properly, then you can get the sense that the world is going crazy, the world is turning, because you are unable to coordinate your own space with the world. So if this is gone wrong, we think that, our brain thinks that the world is spinning. So it's sort of like a miscalculation that the brain does. What if we pump out this liquid? What kind of evil genius thing is this? Pump out the liquid. It's all gravity, my friends. Thanks, Shubham. Thanks for that. What do you call it? Drop in. Nashi. Oh yeah, so alcohol also affects our perception of that. All right, back to vision. Now, rods and cones. What rods and cones does is, rods and cones are cells. So in the retina, there are around, I think 7 million cones and more than 100 million rods. And the purpose of rods and cones, rods will tell us about light. So what is the light intensity? It will tell us if it is dark, is it day, is it night, all of that rods are going to tell us. And 100 million, just imagine that. It is so important for your brain to know, is it day or night and what are we looking at. And cones are only 7 million, and cones tell you about color. So color is not as important as just knowing what you're looking at. So rods will tell you everything about light and cones will tell you about color. Now the interesting thing about cones is that there are 3 types of cones. There is red, blue and green. And of course this is the traditional naming. Now it is converted into short length, medium length and long wavelength cones. But anyway, this is easier to remember: red, blue and green. And literally the way you decide the color of something is again by drawing a XYZ axis. So if you have red, blue and green, and I show you something which is say pink in color, the number of red cones that are getting activated versus the blue cones getting activated versus the green cones getting activated, that decides where the color lies. So if there is a pink color, it will probably be somewhere here. But if I show you a red toy, it will be somewhere here. So the closer it is to red, the more number of red cones are activated, we calculate that, okay, so 80% red cones, 15% blue cones, and 5% green cones. So then the color is somewhere here. But 75% green, 10% blue, and so on. You get that. So it is basically that hexadecimal system. So that is what even computer coders use to define one color. And yeah, so that is how your brain calculates color. Okay. I am not going to private the stream, Cosmic. We have RGB in our brain. Exactly. We do have RGB in our brain. Ayushi Sharma, welcome to Brainstem members. Right? Okay. All right. So, next up. कहाँ तक पहुंचे हम लोग? अभी तक रेटिना नहीं छोड़े दोस्त लोग, जल्दी जल्दी करते हैं. Now, after we reach the retina, now I'm going to draw the two eyes. Okay, and this is the right eye and this is the left eye, and these are the two retinas, right? Now what happens is all those signals that are activated in both the retinas have to enter the brain, and the brain is here, right? So the eyes are in the front and the brain is both above and behind the eyes. So there is something that leaves the eyes called as the optic nerve, and the optic nerve will go back and to the other side and enter into the brain. If I were to draw the image of the brain that you are more used to, if I draw it like this, now if you'll remember, there was a part of the brain at the back. Can you tell me what it was? What is this area called? The part of the back? Anatomy first year. Okay, so this is called as the medulla. Oh no, Bunty. You know who? Amog, no. Okay, Ishika got it. All right, Muskan, Stuti, Rajkumar, Jainil, excellent. All right, awesome. Occipital lobe, very cool. So this is the occipital lobe, and the occipital lobe is at the back of the brain, and this is where all your visual impulse ends up. So your two eyes here, the two optic nerves, all your visual impulses will ultimately end up in your occipital lobe. Now if you look at it from above, अभी हम लोग ऊपर से देखेंगे, so it goes like this. It crosses over and ends up on the other side. What is the significance of this? The world that you see in front of you, if you were to draw a straight line from your nose straight forward, everything to the right side of you is ending up on the left side of your brain, and everything on the left side of you is ending up in the right side of your brain. Okay, and this is the binocular vision. So binocular, so you have two eyes, and you have each eye has something called as the hemifield vision with some overlap in the center. So in the center there is some overlap between the two eyes, but overall the right side of the field goes to the left side of your brain, left side of your field goes to the right side of your brain. Somebody just showing off, strange just showing off Broadman area 17. All right, strange, very nice. Yes, so that is so Broadman areas is every part of the brain has a number, So broadband area 17 and 18 are in the occipital lobe, and then 41, and like different areas have different numbers. So just makes it easier. But yes, right now, this is where it starts to get even more interesting, because we have already said that the world is turned upside down at the retina. Now we know that everything on the right is gone to the left and everything on the left is gone to the right. So basically, if you are to draw a picture of a tree, what you've basically done is you have divided it into two halves and said that this right side will go to the left part and the left part will go to the right. But you've also divided it upar niche, and each one is flipped upside down, and then it is gone opposite. So now try and imagine how your brain is actually seeing the world, where everything is flipped and separated and taken to the other side. And if this is giving you a headache, you can stop. But this is what neurologists have to do all the time when they see a patient who's unable to see things properly, because we have to reverse engineer it, and we have to figure out that if you are unable to see something on your top right, so if there is a big clock in front of you and you are unable to see the 2 o'clock position, where is the problem? So where should that 2 o'clock be in your brain? And the answer is it will be on your left side below. So that is what neuroscience does. But this is roughly how the image enters your brain and goes to the occipital cortex. Now, one thing I wanted to tell you that you might find interesting is that somewhere over here are two structures that you may have heard of called as thalamus. Do you guys remember thalamus? The Ayushi Sharma has asked, why did they mess up our brain like that? Oh man, they didn't. There is a very interesting evolutionary reason why this happened. A little too complex to go in right now, but yeah, has a lot to do with movement, has a lot to do, and this is very closely connected to language and why are most people right-handed, and yeah, it's all connected. We can get to it one after the other, but Aman Chaudhary, very good. It's a traffic cop. Yes. So let's draw it again. Let's draw the brain again, and we spoke about eyes, vision. Going backwards, there is the thalamus over here, and thalamus is the traffic cop. Why are we calling it the traffic cop? Because it's not just the eyes that are sending in signals. Your ears are also sending in signals. So if there is a tiger in front of you, your eyes are seeing the tiger, but you are also hearing the tiger. And if it is very close by, you may even be touching the tiger. So your hands and your fingers may be touching the tiger. And so this is also coming into your thalamus. So your thalamus has to very quickly decide what is important. Because while you are seeing the tiger and hearing the tiger, you may also be hearing the sound of birds. You may also be seeing trees. And you may also be seeing your like the food on the food behind you. But at that time, what is more important, that you hear the birds or you hear the tiger? Obviously you have to listen to the tiger more than listening to the birds. And so the thalamus decides what to let through and what to not. That is why we call it the traffic cop. I call it the traffic cop. And for those of you who are nerds and who have been following up the channel, the amygdala is right here. And the amygdala is what decides what is a threat and what is not. And the amygdala has a very close connection with the thalamus. and your thalamus is constantly talking to the amygdala. Okay, listen, this is all the information that I'm getting. You tell me what is important and what is not. And the amygdala will go through, acha, birds not important, trees not important, array, what is this, this is a tiger, dude, this is super super important, give it full priority. And so as long as that tiger is in front of you, you are not going to be able to see anything else. Let's take a more practical example. You are out camping, and in your tent, you go into your tent and there is a snake. Imagine, do you think you are going to notice if your bag is there or if there is anything else? Your entire attention will be only on that snake, because your amygdala is telling your thalamus that right now nothing else matters, only the snake matters. And that is how, when we talk about perception of space, it is so important to realize that perception of space depends on what you want to perceive. You don't perceive everything. In fact, you perceive less than 5%. Most of it gets filtered out. You don't see most of the things around you, because it's not technically possible to see everything. Your brain will go into an overdrive. So yeah, that is the role of the traffic cop. I won't be discussing the other senses like touch and smell and taste and all, hearing so much. Vision is what I'm going to use as an example for you to understand. I don't even remember by name. More relatable, lizard on the bedroom wall. Oh god. Okay, so yeah, I mean, if you are threatened by the lizard on the bedroom wall, it does whatever you are threatened by. So a snake charmer may not feel that threatened by the snake. So yeah, it all depends on what you are threatened by. Sometimes while playing CSGO, my heart starts to race whether I'm in win or lose position. Does that heart racing help me play good? It kind of does, but different topic. But good point though. It does actually. All right. Now finally the thalamus has decided to let that information go through, and only if the thalamus gives permission, it will reach the occipital lobe. Okay, now finally, after all of this, that visual impulse, whatever you have seen, has entered the occipital cortex, which is the brain. So finally, now your brain, your cortex knows what is happening. And there are a couple of interesting corollaries to this. It means that your thalamus and your amygdala actually know what is happening around you much before you know it. And I don't know if this makes sense. I don't know if you understand what I just said, but your amygdala knows a threat before you know the threat, and your amygdala has already decided that this is what you should look at and this is what you should ignore. And the important thing is that you perceiving space depends on what you consider as a threat and what you consider as not a threat, right? So yeah, just keep that in mind, and if you keep thinking about it, you will realize many corollaries to this information. Now let's talk of the occipital cortex. And I've never talked about the occipital cortex much, but it's my, probably after the PFC, it is my favorite part of the brain. It's so weird to have a favorite part of the brain, but yeah, I do. Some people are bad with direction, say while driving. We'll talk about that. We are getting there, right? Okay. Like the stream, guys. Like the stream. Hit subscribe. Follow the channel, guys. Okay. I'm supposed to do that now and then, apparently. So here we are at the occipital cortex. क्या होता है occipital cortex में? The occipital cortex is very nicely divided into layers, and they are called as V1, V2, V3, V4, V5. There are a total of 8 layers. Roughly speaking, it's arbitrary, but this is what oh my god, you know who has just made an amazing comment. I love it. I love it. Which like button is real? Upward thumb or downwards thumb? Oh my god, that's the kind of mindfuck moments we live for. Yeah, this stream has been paisa vasool already. You know what? You know who? Yeah, you get mod for that. Let's see. Alright. Click, bloody well, click the right one, okay? Alright. So, back to the occipital cortex. V1 to V8, and V1 is at the back, and as it goes forward, it goes up in number. Why is this important? Think of it as each layer, as you go forward, increases in complexity. Right? So V1 will be the simplest form of processing, and as you move forwards, the processing power of the occipital cortex increases in complexity. So what does that mean? If you are seeing a tree and the retina has already broken it down into millions of small photons, so all the light particles that are reflecting off of the tree are hitting different cells in the retina, right? And these different cells are getting transported into the brain in different nerve fibers, and all of these will come together to form a very thick band called as the optic nerve, and this will end up in the thalamus, and then it will end up in the occipital cortex, and it will go all the way to the back. So this is the eye. It will go all the way back to V1. Now once V1 is done with processing, it will hand over that information to V2, then V3, V4, V5, V6, and so on, right? This is roughly speaking. What V1 does is, remember that you are not seeing the tree, because when the information reaches V1, it is not coming in the form of a tree, it is actually coming in the form of small units of information which are parts of the tree. So whereas a tree should look like this, what V1 is seeing is just this, right? So any one cell in V1 cannot understand what we are looking at, because one single cell will only be able to see this. Now if we look at this, can you tell if this is a tree? So quite literally, the process of the occipital cortex is the process of seeing the big picture. So each cell in the occipital cortex in V1 will have a role of understanding what this is. And in V1, there is something called as simple cells and complex cells. So every information that enters into the occipital cortex comes across as a shape. Now there are different cells that are designed to perceive straight lines, to perceive curves, and to perceive edges. And there are different cells that are designed to perceive straight lines in different angles. So if there's a straight line that is coming in 180 degrees, and if there's a straight line that is coming in say 45 degrees, then there will be a different cell that gets activated when there's a line coming in like this, and a different cell that gets activated when there's a line coming in like this. And these are all simple cells. Complex cells will increase the complexity by 1. Complex cells will take what the simple cells have seen, but they will get activated if those lines are moving. So as soon as a line starts to move, the complex cells will start getting activated. And the complex cells are much more sensitive, which is why movement is so important for perception. Now, imagine that there is a line, okay, like this. Now imagine, say, the second hand of a clock that is moving continuously. Okay, can you imagine that? If there's a clock and this is the second hand and it is constantly moving in a circle, every time that line turns from this to this to this to this, a different cell is getting activated and a different complex cell is getting activated depending on the direction, because there will be one complex cell that is activated in this direction, another one in this direction, another one in this direction, another one in this direction, and so on. So think about the amount of work your occipital cortex has to do just to perceive something moving. So when I'm doing this and you can see this pencil moving up and down, your complex cells in your occipital cortex are just going haywire trying to figure out the direction of movement. But this is so important in perception because movement is given much more importance from an evolutionary perspective. Now, I wanted to show you something. Yes. So if you can see this diagram, tell me what you see. This diagram, this black and white image, tell me what you see in this image. You see a bear, correct? Yes, you see a bear. You see the bear in a jungle. There are some trees, there are some plants, bear in a jungle, cute bear, cool. When you look at such an image, you feel like your eyes are moving very smoothly across the screen, right? You look at the bear and then your eyes glide towards the trees and then you see the ground and you see the black and white image. But actually, the way your eyes move is like this. So your eyes don't move in a very smooth way. Your eyes are actually moving in a very, very, very chaotic way to try to fill the gaps. And what is very interesting is that there are entire spots where your eyes have never touched. They have never rested because those are spots that don't have any signal. So either they are completely black or they are completely white, and you will primarily focus on the bear, which is why there is a lot of movement here, and you are just trying to fill in the shadows here and here. That is how your eyes move in order to complete a picture. And the way they figured this out is by actually attaching electrodes to the eye to pick up on something called as microsacchards, to pick up on something which is very, very, very small, right? And this research was done many years ago, I think 30-40 years back. Let me give you another example. Look at this, look at these two faces. When you see them, just look at the faces, right? And just see, look at the eyes, look at the nose, just see the faces as you would normally look at any picture. And now look at how your eyes have gone across them. So your eyes did not stop at a lot of places like the hair or the forehead or the cheeks, but the most important points in any face that you look at are the eyes, the nose, and the overall structure of the face. That is all you need to look at. So if you were very aware, especially in this face, you would have only seen the eyes and the nose and the outer structure, and your eyes did not pause at the hair or this piece of shadow here, because you didn't need to. There was nothing that is stimulating your eyes from that spot, right? So this is how movement plays a role in our perception of space, because our eyes are actually not looking at individual points. It is actually doing something called as filling up empty spaces, and there is a term for this which is called as illusory contour perception. Now, when you look at this word illusory contour perception, what does the word mean to you when you think about this? The word illusory means illusion, contour means edge, and perception is how you see it. Now, there are, like how I said about simple and complex cells, there are cells in your inside your occipital cortex called as end point cells, right? And what these cells do, they are also called as end stopping. So what these cells do is, suppose there is if I draw suppose if I draw a, what's the best color? Black is not a good option for this. 1 second. Anyway, suppose if I draw a square like this, there is a chance that you will only see this yellow, and your eyes are not really looking at any of the dots inside here until I drew those dots, because there is nothing stimulating your eyes, and your brain is actually just filling up the color inside without having to look at the color, because it is more efficient. Let me give you an example with this. So this is a good example of illusory contour perception. So if you see that, are you able to see the square? The idea is that actually there is no square in the middle, but your brain will now create a square, because that is illusory contour perception. So the contour ends here, 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 and because the contour ends here, your brain actually, instead of looking at it as 4 Pac-Man put together, your brain actually sees the square first because of illusory contour perception. And this is a very key. I can't unsee the square, I tried. So that is what it is. Siddhartha suggested Gestalt. Yes, so Gestalt talked more about color, but yes, he did talk about illusory contour perception as well. We will discuss this. We'll discuss Gestalt separately. Yeah. So, yeah. Now we are going to leave the occipital cortex, because we have talked about it enough. Wait, hang on. And now we will talk about what happens once the image is formed. So there is a tree. It got broken down into many dots. All that information reached the occipital cortex. It went from V1 all the way to V8. uh, one by one, every layer, a new piece of information got added. We understood that there are lines, we understood that there are curves, we understood that there is movement or there is no movement. For example, v3 and v5 also adds color, so we understood that okay, so this is green, this is brown, whatever. And by the time the information reaches till here, we have a pretty decent idea as to its shape. That's it. All we know is an overall shape. Now what? We see the shape, but now what? Or if we want to make it more interesting and you want to see my drawing again, I can draw a tiger. Okay. So there is a tiger and but we don't know that it is a tiger yet. All we know is that this is the overarching shape of that object. Now this piece of information gets sent to two places in the brain, and this sending of this information to two places is called as dorsal stream and ventral stream. So dorsal means above and ventral means below. Dorsal could also mean back and ventral could mean front, but here dorsal means above. So the stream that goes above goes to this place called as parietal lobe. Brain was streaming before it was cool. Yes, absolutely. And the ventral stream goes to the temporal lobe. Why does it do this? Because when you get this information of what you are looking at, there are two things that you really want to know. One is, what am I looking at? And second is, where is it? So what is it and where is it? Both of them are equally important. You have to know that it is a tiger, and you have to know that, is the tiger in front of me? Is it behind me? Is it going away from me? Is it coming towards me? Because that makes all the difference. If you don't know any one of these, you are dead. Both of them are equally important, right? So no wonder our brain is looking at Sid's drawing and says that's not a tiger. This is so bad. This is so mean. Okay, I'm just going to sit and practice drawing tigers now. I'm going to upload a picture of me drawing a tiger on Instagram after this. What is this? Focus on the important piece, okay? Focus on the important information I'm giving you. All right. So the dorsal stream goes towards the parietal lobe and the ventral stream goes towards the temporal lobe. The temporal lobe is where you figure out what I'm looking at, and the reason is the temporal lobe is what contains all your memories. So if you've never seen a tiger before, would you know it is a tiger? Temporal lobe also contains your language centers. So that is why when you look at a tiger, you are able to think of the word tiger, and you are able to think of the concept of tiger. Now these are two different things. So the word tiger and the concept of the tiger are both different. So there are people who have named their dogs as tiger. So for them, the word tiger may mean the dog, but the concept is everything. So if you say that tiger is chasing you, which concept of tiger is chasing me? If it's my dog, it's fine. If it's a real tiger, it's a problem. So all of that is in the temporal lobe. Today, we are not going to talk about the temporal lobe much. What we are instead going to talk about is the parietal lobe, because that is what is more important in understanding space. So the information has reached the parietal lobe. What the parietal lobe is very, very good at doing is creating a three-dimensional map. So think about what it means to understand where the tiger is in our environment. You need to know, one, the tiger itself, you need to see it, and two, you need a three-dimensional space in order to place that tiger in it. So you need to see how far the tiger is from you. So that means that, one, you need distance. You need to calculate distance. You need to calculate movement. You need to calculate depth. Right? So all of this is what spatial awareness means. And this is neuroscience of space. This is what it means to know what is the space around you. So here we have one specific target, which is the tiger, but you also need spatial awareness to know where the tiger is. And somebody has asked, what about the scale of the tiger? So absolutely. So all the details of the tiger itself on the one hand, and all the details of the environment in the other hand, and you have to put these two things together, because without any one, the picture is incomplete. You may have a very, very detailed description of the tiger, but if you are unable to see the environment, how will you place it? Where will you place that tiger? Right? So it's sort of like augmented reality. If you think about it, that what augmented reality does, AR, what it does is it creates, say, a three-dimensional structure of a tiger, and it takes a video of your real world environment and it places this in a real world. What is the difference between augmented reality and virtual reality? In virtual reality, both of these are digital, whereas in augmented reality, only the target is digital, the environment is real. So that is how so that is how technology is evolving. That is how we are trying to reverse engineer what our brain is doing. Now, how does the parietal lobe have a three-dimensional awareness? All the senses that end up in the thalamus, all of them ultimately go to a place in the parietal lobe called as the somatosensory cortex. The somatosensory cortex is the part of the parietal lobe that is responsible for being aware of all sensory inputs. And what is very interesting is that in your brain, if you look at it, the parietal cortex is here, the occipital cortex is here, and your temporal cortex is here. And there is a place at the meeting point of all of these called as the parieto-temporo-occipital junction. And this area where information from what you see, what you hear, what you touch, everything combines together with also what it is that you're looking at, what you're hearing, what you're touching. All this information comes together and meets up in this common area on both sides of your brain. And this is where reality is formed. Does this start to make sense? Patna Junction. Please turn over junction. All right. I'm glad that this is making sense to everyone. Jalebi Junction. All right, guys. All right. Now, why is this important? there is two kinds of space. One is, when we talk about space, one is external space and one is internal space. And this is where that first point came about, that why don't parents give children space? External space is what we've been discussing so far. The idea of three-dimensional structures around us. There is a tiger inside. You need to be aware of everything around you, the trees, the birds, the sky. All of that is external space. Internal space is you knowing where you are, your body position. So you knowing, are you sitting or are you standing? Is your head straight or is it theta? Where is your hand? Where is your leg? That whole awareness, which, as somebody said, my space, you can also call it as personal space. So at any given point, you know how far the wall is from you and how long your hand is and how tall you are, which is why when you walk towards a door, and sometimes if the ceiling is too low, you will duck, because you are able to calculate that this is my height and that is the ceiling, and you will know how far somebody is, so that when you stretch out your hand, you don't accidentally bump into them, because you are aware of your personal space, and as your hand extends, your personal space is extending. So your brain is constantly calculating the interplay between external space and personal space. What I found very interesting is the middle ground between them, and there is something called as peri-personal space. And this is the space that is just outside of your body, but this is where you are aware that if somebody enters into this space, it can be a threat. And this is the part that you say that, get out of my personal space, get out of my space, I need some space. So when somebody is very, very close to you without touching you, I remember in school, there would be kids who would do that, get really close and say, hey, what, I'm not touching you, right? I'm not touching you. Why are you angry? I'm not touching you. But they are ignoring the idea that there is something called as peripersonal space, which is also a threat. And whenever somebody is in your peripersonal space, your amygdala is getting activated. Now, like a bubble of space, SCK, exactly. And okay, E1LG. Oh, that sounds like a gadget name. That's super cool. Thank you for the super chat, Evan. Hi, I'm a student learning deep learning. I wanted to ask how accurate are convolution networks from a neuroscientist perspective, if you've heard about them. Evan, can you talk about convolution networks? What do you mean by that? Yeah, because I am very curious what you mean by convolution networks. Right? Oh, Himanshi is here. Hi, Himanshi. Hi, Abhishek. Welcome to the chat. Okay. So the peripersonal space is sort of like an extension of your personal space. Let me give you an example. Suppose you pick up a knife. Now, as soon as you pick up a knife, what you have done is, if say this is you and your personal space was right here, right? This is your personal space and your body is aware that this is you. The peripersonal space would probably extend till all around like this. And there are three things that you have to remember about the peripersonal space. One is that anybody enters is a threat. Two, that all the objects in your peripersonal space are available for manipulation. And what that means is that if there is a knife in your peripersonal space, that means that you can now use that. And as soon as you pick it up, that knife becomes a part of your personal space. And so your personal space extends around it, which is why you know that when you pick it up, it's almost as if the length of your hand has increased. And this is how basically kill distance, exactly like in Among Us. And this is how, as it's almost as if you have a bubble, your brain has constructed a bubble, and as soon as you pick up something, you are taking something into your bubble, and you are letting something come in from the external environment into your personal space. And this has a lot of corollaries, including in romance. So in romance, also there, in physical romance, there is situations where somebody has entered into your peripersonal space, and which is why anyone who enters into your peripersonal space initially is a threat. But here you are allowing them to enter, which is why that combination of threat plus desire is what makes somebody coming physically close exciting. Because if you think about it, fear and excitement have a lot of similarities in the way your body reacts, in that your heart is racing and all of that. And the reason that your heart is racing is because of amygdala activation. So when somebody comes very close to you and your heart is racing, it is because of this threat. But the reason that you don't fight them off is because you wanted them there. And which is also why, if the threat completely goes away, if say you are absolutely not threatened by them anymore, the excitement can go down because your amygdala is no longer activated every time they enter into your peripersonal space. All right, so that is about okay, now let me quickly see what all you guys are talking about. Good one said home is our peripersonal space. Absolutely, home is our peripersonal space. Better than neural networks. It's basically something better than neural, reduces the learning features and parameters. Convolution networks. Okay. Is this aura? No, this is not aura. So the concept of aura, I mean, it's not neuroscientifically proven, but the idea is that it's heat signatures. So something about infrared and all that. But I mean, I've very briefly tried to read about it, but couldn't find anything very good. Even LGA said Google this 2D visualization of convolution neural network. Click on the second link. It's an online app. It will give you a very clear idea. Awesome. All right, I will find this out. 2D visualization of a convolutional neural. Can someone just paste that link here, please? That'll be very, very useful. If you can just paste the link here, we can check it out. Yeah. All right. So what else do we have? What time is it? It's 11. How long do you want to continue? There are some things still left to talk about. Are you guys enjoying this? Is that why new ways of romance are figured out? आप Discord और YouTube जवाब ही नहीं देते. Oh man. ऐसा मत बोलो. I try to reply as much as I can. Try explaining peripersonal space in Mumbai locals. Oh God, there is no peripersonal space in Mumbai locals. There is no personal space. There's only public space in Mumbai locals. Yeah. Did we cover directions? We didn't cover direct. We covered directions a little bit. Yes. Do we dream more about the home we grew up? Abhishek Patel has asked. Thank you for the super chat, Abhishek. So we tend to dream about things that are, there is nothing like that, by the way. There's nothing like that. We tend to dream about, uh, there are different theories. So one of the theories is unresolved issues. So if you're trying to create new memories, we are trying to solve a problem, if you're trying to resolve an issue, resolve a conflict, you may tend to dream about that. But it's very possible that it is completely random. Astrophysics, Bharat, I told you, like, we are definitely doing astrophysics, but probably like in a couple of weeks. Yeah. Parietal lobe is related to imagination. Absolutely. So let's talk about that. That's a great point. Let's talk about, wait, let me add more papers here. Also, have you guys been doing your homework on getting 100K subscribers? I've realized that I should be a little bit more strict in this. I'm being very relaxed. It's already like mid-November, guys. It's already mid-November. What is this? Will this be available on Discord? Yes, I will share this I'll share this entire note on Discord. Yeah. Ignored OP. Sparsh. No. I'm not ignoring you. Ask Samay. Yeah. Keep drawing that tiger and we'll get 200K. Alright, I'm going to draw that damn tiger. I will draw a shaded tiger that will put other tigers to shame, okay? And I'll put it up on Instagram. बहुत हो गया. बहुत हो गया. Okay, couple of points more. Somebody talked about daydreaming, and I think that is a very interesting point. We should talk about it. How does it happen? In your parietal lobe, okay, think about it this way. Put your hands above your ear, right, like this. Put your hands on both sides of your head. What you are touching is your parietal lobe, right, like this. Now the parietal lobe has an outside and an inside, right? So if you look at it from, say, now this we are looking at it from the side, so here you are looking at the outside of the parietal lobe. But suppose I remove this, okay, and now suppose I cut out a piece of the brain and I'm going to look inside. Yeah, so here we are looking at the inside part of the parietal lobe, and this is the outside of the parietal lobe. The outside part of the parietal lobe deals with the outside world, and the inside of the parietal lobe deals with inside your body. So your perception of yourself, your idea of what you look like, what you are shaped like, your body image, this has a lot of corollary. So body dysmorphism, so people who may think of themselves as too fat or too thin, or feel like I have a weird nose, all of that part of the problem. So there's also the insula that is activated, but part of the problem is because your body self-image is a little screwed up. But assume that that is not there. This is the part of your brain that figures out where you are. And the outside part of the parietal lobe is figuring out what the outside world is. And right below over here is where the hippocampus is. Okay, and the hippocampus is where all your memories are stored. Cool. So what are the three areas I talked about? Outside parietal lobe, outside world. Inside parietal lobe, yourself. And hippocampus, memories. Think of what all these three things can do together. So your memory and your hippocampus, which by the way, your hippocampus has something called as place cells, which I briefly mentioned when I talked about neuroscience of Among Us. But place cells can make you imagine. It is basically like uploading a disk. So the place, if suppose I have gone to Croatia, which I have, and all the memories I have of Croatia, the roads, the way the beach is and the promenade and all that, there is a place in Croatia called as Zadar, which is beautiful. And now I'm imagining Zadar. And the reason that I'm imagining Zadar is because my hippocampus place cells have installed this memory. So it is there. And as soon as I say Zadar, that thing gets uploaded. Now, in my brain, Zadar is uploaded. Now what I have to do is yes, flex, absolutely, Shatrunjay. यार अभी 8 महीने से घर पे बैठा हूँ, so this is allowed. Parietal lobe, the inside of a parietal lobe will now come up with an image of you. And then it is literally putting 2 and 2 together and putting the image of you overlapping it with an image of the place. And next week when we talk about time, we will also talk about how literally you can take yourself and move yourself across any space and time. And this is called as imagination. And a more interesting word is autonoetic consciousness. And I would recommend that you Google this and read about it. Autonoetic consciousness is when you are able to take yourself and transport yourself across space and time. And it may even be in the future. So you can even visualize what will happen if I take up this job? What will happen if I move to Dubai? What will happen if I move to Kerala? Or what would have been if I had taken up that job instead? So all of these things you can imagine and put yourself there and try to figure out. So the autonoetic consciousness is supposed to be a great way to learn things without actually having to live through them. So if your imagination is good enough, you can actually do that. So that is how imagination works. Like astral travel, like literally or theoretically, Monsieur Nick. But then that is what it is, right? That what is reality? Because reality is also your parietal lobe getting activated through impulses, and imagination is also your parietal lobe getting activated through impulses. So it actually brings it into question, and it is even more in question when we bring in virtual reality. And virtual reality is something that we are going to talk about on a separate stream. We will talk about the neuroscience of virtual reality, but it is very important for you to have known all of this when we talk about virtual reality. But I'll be calling a couple of very interesting folks to discuss that. And yeah, I hope that you guys will have. All right, I think that yeah, it's 11 o'clock. This was a good talk. This was a good conversation. I hope that you guys all liked it. I'm sorry if I missed a few chats. Abhishek Patel, thank you for the super chat again, Abhishek. Stage fear, can you explain it? All right, so the idea of stage fear is that it's actually a okay, it's okay. I'll take out 5 minutes and explain it. Why not? When you see someone, you are looking at them and they are looking at you, and it actually has a lot to do with your temporoparieto-occipital junction. कहाँ गया? मैंने किधर बनाया? हाँ, ये ठीक है. Your parieto-temporo-occipital junction, like I said, reality is formed. What your TPO also does is just like autonoetic consciousness, where you are able to transport yourself across space and time, you are also able to transport yourself across people. So you are able to take yourself, and instead of transporting through a different space, you are able to transport yourself onto somebody else's situation. Okay, and this can be called as empathy. And mainly the right side of your brain, the right temporoparietal junction, that is what does this. You are able to put yourself, like take yourself and put yourself in somebody else's shoes, quite literally, and that is how you are now able to perceive what they must be thinking. So this is called theory of mind, and every child goes through this and adults go through it, and at some point we stop trying to think about it too much. But if you keep evolving this skill, it is almost like mind reading, because your brain is capable of high levels of empathy, and you are able to understand what somebody else is going through just by looking at them, talking to them. You perceive their body language, all of that stuff. Now, why is this important? If you are in a jungle and you come across somebody that you don't know, you are wondering, is he going to kill me? Right? You are under threat. You don't know whether that person is going to attack you or not, which is why this skill is super useful. This theory of mind skill is very, very useful, because empathy, you know, now you see their expression, you see their body language, you see the words that they use, and all of these things put together, you now come to the conclusion that it is a threat or not a threat. Right? With me so far? Now, suppose you are not able to see them. This makes it an unknown, and every unknown is a threat. What happens if you are wait, okay, what happens, my page has changed, but okay, what happens if you are faced with many people? The problem is that you are now not in a position to read everybody's mind. You are not in a position to empathize with everybody, and there is a lot of information coming your way. And so there is an immediate level of threat, because you are not only outnumbered, but you are also, you are not sure if are these people going to harm me or not. So this is the most primitive level of fear, that there are many people in front of me, and so empathy goes a little haywire, because empathy needs eye contact, empathy needs to see body language. But if there are a lot of people, there is too much information coming in. That is level 1. Level 2 of stage fear is that fear of loss of validation. The biggest problem in society is that you are constantly afraid that your society will reject you, your peers will reject you. And this also has a very primitive sense. So if they throw you out of the tribe, you are going to die. So the approval, public approval, is very, very important. So it is better to not go on stage and not have public approval rather than have public disapproval. So being invisible can be better than having public disapproval. So that is level 2 of fear. And level 3 is loss of identity. So who you are as a person, if you feel like you are confident and successful, and you go up on stage and you fail, then in front of everybody your identity is lost. So that is level 3 of fear. So there are many reasons why stage fear exists, but yeah, I hope that that was playing safe, basically. Absolutely. All right, all right. That was a random stage fear explanation, but okay. I hope that that was useful for you guys. Yes, everyone, please pay attention to this. Our chess tournament is starting tomorrow. Please join my Discord channel. Go on to, so chess tournament is already, I think the registration is full, but next week we are going to have Scribble tournament and Among Us tournament. And the finals of chess and Scribble will be in the last week of this month. And we are also going to have a poker tournament, a small one, in the last week of this month. Right? So yes, join Discord and I'll give you the rest of the information there. Yeah, I think Deblina Datta, thank you so much for joining as a member. You've joined medical students. I hope you are a medical student. I will be starting medical clinics next week. I just got a very nice book called De Jong, the new edition, and I've been reading that. So yeah, I'll be taking neurology clinics. So I'm glad you joined. Spread the word to, if you are a medical student, then spread the word to other students as well, because I will be taking medical clinics as members only. It is not going to be open for everyone, but the medical student membership is quite cheap, so it's okay. Bhavya Trivedi already joined. Bhavya, I don't think so, because then I would be able to see it. There would be like a membership mark next to you. So, oh, GPT-3, I've read all about that. E1. It's very interesting. It's very, very interesting. Neuroscience of meditation. Tanmay Saha coming back from his break. Absolutely up to him. We will see what happens, but I'm sure something or the other will keep happening. So yeah, how is claustrophobia perceived? Okay, no more random topics. I think I explained stage fear. Let's do it one at a time. So I hope that you understood neuroscience of space. There is a lot that I didn't cover, because it is not technically possible to cover everything, but we will do more on this. And the next one will be on neuroscience of time. That is probably after 2 weeks. Next weekend is Diwali, so I wish you all a very happy Diwali in advance. And I hope you have a lot of fun. Make video on your life. All right, Lokesh, what about my life? I think you all know it already. No for Discord. Oh, for Discord, already joined Discord long time ago. Okay. He watches the streams. Cosmo. All right. Sparsh, I have a small podcast. Intellectual discussion. That's nice of you, Sparsh. The only problem is time. There is a lot of time crunch happening now. I am extremely sorry if I have to say no, because there is, yeah, it's been a little nuts, to be very, very honest. But I wish you all the best. I hope you have a great podcast experience, and open brain surgery video, really. All right. I actually thought of doing a video on just my so a lot of people were asking me what are my qualifications. So maybe I'll do a video on that. Just what I've done and stuff. But it feels, let's see. What I want to do is I want to do a talk on how to prepare for exams. But I think I'll do that for the medical students. Yeah. All right. Medical students and mods. That might be fun. Okay, guys, any questions? Any questions on bring astrophysics back? Absolutely, Bharat. You can rest easy on that. We are absolutely bringing astrophysics back. Lokesh, how do you feel when you do surgery? I feel like I really shouldn't be doing this because I'm not a neurosurgeon. So I'm a neurologist, so I don't operate. So whenever I do operate, I feel like, what if somebody catches me? I am joking, I don't operate. Make neuroscience of psychedelics. It is on my mind. I wanted to do psychedelics and alcohol together. So if I can, I will. Yeah. No talks on exams. Do something which we can't normally get outside. All right. Your views on switch to next. Oh God. I read about it, and yeah, I don't know what to make of it, to be very honest. They keep changing the rules so many times. It's getting annoying. Could you do the neuroscience of space and time? So this was space, by the way. I know there is a lot we haven't covered, but this was the introduction to space, and we will do one on time. With Mansi, we are doing it next month. We will be back with a bang. We will talk about netizen psychology and criminal psychology. One stream of poetry, neurology of poetry. I'm not a medical student, by the way. Oh, that's okay, Energy. I think you became a Brainstem member, right? Yes, you became a Brainstem member. So the medical student membership was created just because students, yeah, I mean, it was sort of like the cheapest membership available, so that medical students can join in, you know. Yeah, but all the streams that are for medical students, if you are already a member of any category above that, you are also welcome to attend the clinics if you want to listen to neurology, that is, because that will be all about patients and how to approach clinical cases and how to give exams and all of that. Yeah. Can space itself be perceived through other senses? So we will talk about other senses in a separate video, because I am interested, to be very honest, but I'm also a little hesitant to talk about extrasensory perception because I haven't read enough about it. I had fun. Good night. Thank you, Sparsh. I had fun too. This was a lot of fun. You guys are awesome. Okay. All right. Yes, I think that's about that. Yes, I think I covered everything. Yes. He streams at late night. Right. Chalo, have a wonderful rest of Sunday, guys, and have a wonderful week. I shall see you soon. I'll be doing a random gaming video sometime this week. I'll play a couple of games, and I'll see you soon. Yeah. Chalo. How does, yeah, I'm going to draw a tiger and put it up on Instagram. So join me on Instagram. Yeah, this feels very shameless. Forget it. It's okay. Chill. You do you. Rest of Sunday, seriously. All right. 40 minutes of Sunday left. Hey, a lot of things can happen in 40 minutes, okay? A lot of things can happen in 40 minutes. Social awkwardness, Priyanshu, we will talk about that. We will talk about that. And I'll try to answer more questions on Discord. I'm sorry about that, by the way. I'll try and answer more questions on Discord. I'll try and find time for it. Yeah. Which games? Raji for one, Valorant for another. All right. All right. All right. Chalo. Learning medicine. So, Deblina, if you've become a member, you will automatically get into that learning medicine group. I'm going to set it up in a couple of days as soon as I start the medical clinics. Yeah. So all the members of YouTube will get access to that learning medicine group, and that is where I'll be sharing all my medical notes as well. So yeah, tell your medical colleagues as well. Chalo. See you. Good night. Thank you for being such a lovely audience. I'll see you soon. Bye.